Hello my friends and welcome back to Sky Creative Channel. From soaring through the clouds to precision sports equipment, today we'll explore 5 incredible manufacturing processes that showcase the pinnacle of modern engineering. So let's dive into the fascinating world of industrial excellence. Step into the Cathedral of Aviation Engineering, Airbus's final assembly line in Toulouse, France, where the magnificent Qatar Airways A380 takes shape. This isn't just manufacturing, it's orchestrated precision on an almost impossible scale. The A380, weighing in at 575 tons when fully loaded, requires a production facility that's literally the size of several football fields. The journey begins with the fuselage sections arriving via specialized transport, some by road using custom-built trailers, others by the famous Beluga cargo aircraft. Each Qatar Airways A380 fuselage section is precision manufactured at different Airbus facilities across Europe. The forward and aft sections come from Hamburg, Germany, while the center fuselage arrives from Toulouse itself. Watch as massive overhead cranes, each capable of lifting 150 tons, delicately position these enormous aluminum sections with millimeter precision. The structural joining process uses a combination of riveting and advanced bonding techniques. Qatar Airways specifications require over 400,000 rivets per aircraft, each installed by automated drilling machines that ensure perfect alignment and consistent tension. The wing attachment process is particularly mesmerizing. Each wing weighs approximately 45 tons and must be attached with absolute precision. We're talking tolerances of less than 0.5 millimeters. Specialized hydraulic jigs hold the wings in perfect position, while robotic systems drill and install the critical attachment bolts. These aren't ordinary bolts. Each one is precision machined from titanium alloy and torqued to exact specifications using computer-controlled tools. Now comes the transformation from aircraft shell to luxury flying palace. Qatar Airways A380 interior configuration is one of the most complex in the industry. The installation begins with the aircraft's nervous system, over 300 miles of electrical wiring that connects everything from cockpit avionics to passenger entertainment systems. The cabin installation process is like watching an incredibly complex puzzle come together. First, the floor panels, each one custom cut and fitted with integrated lighting and power systems. Then comes the framework for Qatar Airways, famous first-class suites, each requiring precise positioning to ensure passenger privacy and comfort. The business class seats follow, with their complex mechanical systems for lie-flat functionality. What's fascinating is how specialized robotic systems install the overhead bins, each one precisely measured and fitted to maintain the aircraft's weight distribution. The galley installations are particularly impressive, with stainless steel units that must connect perfectly to the aircraft's water, waste, and electrical systems. The Rolls-Royce Trent 900 engines arrive as complete units, each worth approximately $20 million. These engineering marvels produce 70,000 pounds of thrust and contain over 150,000 individual components. The engine mounting process requires specialized lifting equipment and precise alignment systems. Simultaneously, technicians are installing the aircraft's sophisticated systems. The environmental control system, which will keep passengers comfortable at 40,000 feet, involves miles of ducting and precision-calibrated control units. The hydraulic systems, operating at 3,000 psi, power everything from flight controls to landing gear, each connection tested multiple times for absolute reliability. The avionics installation is particularly impressive. Qatar Airways A380s feature some of the most advanced cockpit technology available, with displays that provide pilots with unprecedented situational awareness. Each system undergoes extensive testing using computer simulations before the aircraft ever leaves the ground. Before this magnificent machine can carry passengers, it undergoes the most rigorous testing imaginable. The structural integrity tests involve applying loads that exceed anything the aircraft will experience in service. Hydraulic jacks apply forces equivalent to 150% of maximum flight loads, while laser measurement systems monitor for any deformation. The system's testing phase is equally thorough. Every light switch, every entertainment screen, every galley appliance is tested multiple times. The aircraft's computers run thousands of diagnostic checks, ensuring that every system communicates properly with the others. The paint process deserves special mention. Qatar Airways' distinctive burgundy and white livery requires multiple coats of specialized aerospace paint applied in climate-controlled hangars. The painting process alone takes over a week, with each coat requiring specific drying times and conditions. The culmination of thousands of hours of precision manufacturing. First flight. Watching this 575-ton giant lift gracefully into the sky is nothing short of miraculous. From the initial structural assembly to this moment of flight, every component, every system, every detail has been crafted to the highest standards of precision and safety. This Qatar Airways A380 represents more than just transportation. It's a testament to human ingenuity and the incredible precision of modern manufacturing. In the next segment, we'll shift gears dramatically to explore precision manufacturing on a much smaller scale. Welcome to Trust Cartridges, where precision isn't just important, it's literally a matter of life and death. This state-of-the-art facility produces some of the most reliable ammunition in the world, serving military, law enforcement, and competitive shooting markets. Every cartridge that leaves this facility has undergone quality control processes that would make a Swiss watchmaker envious. The production floor buzzes with automated machinery operating under strict environmental controls. Temperature and humidity are maintained within tight tolerances because even microscopic changes can affect powder characteristics and dimensional accuracy. The journey begins with brass billets that are transformed through a series of precisely controlled forming operations. The deep drawing process uses hydraulic presses capable of 200 tons of force, progressively forming the cartridge case through multiple dies. Each die is precision machined to tolerances of plus or minus 0.0005 inches. That's thinner than a human hair. The annealing process is critical. Brass cases are heated to exactly 750 degrees Fahrenheit in controlled atmosphere furnaces to achieve the perfect balance of strength and flexibility. Too soft, and the case won't withstand firing pressures. Too hard, and it becomes brittle. Automated inspection systems use laser micrometers to measure wall thickness at multiple points, ensuring consistent performance. The bullet manufacturing process is equally impressive. Lead cores are precisely weighed and formed using automated machinery that maintains weights within plus or minus 0.1 grains. The copper jacket forming process uses progressive dies to create perfectly uniform wall thickness. The swagging process, where core and jacket become one, happens under tremendous pressure, up to 50,000 psi. This process must be absolutely consistent, because even tiny variations in bullet weight or shape affect accuracy and ballistic performance. Quality control systems check every thousandth bullet using X-ray technology to detect any internal voids or inconsistencies. The final assembly process brings together case, powder, primer, and projectile with robotic precision. Powder charges are measured using electronic scales, accurate to plus or minus 0.02 grains. That's incredibly precise when you consider a typical charge weighs just 25 to 40 grains. The seating process uses computer-controlled presses that ensure consistent overall length and proper bullet seating depth. Every cartridge undergoes multiple inspections: case dimensions, overall length, bullet seating depth, and primer seating. But here's what sets Trust cartridges apart: statistical sampling testing, where cartridges are actually fired in precision test barrels, with computer systems measuring velocity, pressure, and accuracy. This data feeds back into the production process, ensuring consistent performance batch after batch. The result? Ammunition that delivers the reliability and precision that professionals demand, manufactured with tolerances that rival precision scientific instruments. Step inside Weissgolf's cutting-edge production facility, where German engineering precision meets innovative golf ball design. Weiss has revolutionized the golf ball industry by combining traditional manufacturing excellence with breakthrough materials science. Each ball represents over 18 months of research and development. The magic begins with core formation using a specialized injection molding process. The proprietary rubber compound is heated to exactly 347 degrees Fahrenheit and injected into precision molds under 15,000 psi pressure. The multi-layer construction process is fascinating to watch. Each layer serves a specific purpose. The inner core provides initial velocity, the outer core controls spin, and the mantle layer fine-tunes feel and control. Specialized molding equipment applies each layer with precision positioning systems, accurate to plus or minus 0.001 inches. What's particularly impressive is the urethane cover application. This isn't simple molding. It's a precision casting process where liquid urethane is applied in a controlled environment, creating the perfect balance of durability and feel that Weiss golf balls are famous for. The dimple pattern creation is pure engineering artistry. Weiss's proprietary 336 dimple pattern is created using laser-cut molds that position each dimple with mathematical precision. The depth variation: some dimples are 0.0045 inches deep, others 0.0040 inches, creates the aerodynamic properties that give Weiss balls their exceptional flight characteristics. Welcome to Johnsway in Taiwan, where precision tool manufacturing reaches an art form. For over 3 decades, Johnsway has built a reputation for producing professional-grade tools that mechanics and technicians worldwide depend on. Their facility represents the pinnacle of precision manufacturing, where tolerances are measured in microns and quality control is obsessive. The facility operates under ISO 9001 and AS 9100 standards, serving aerospace, automotive, and industrial markets. What sets Johnsway apart is their vertical integration. They control every aspect of production from raw steel to finished tool, ensuring uncompromising quality at every step. The journey begins with premium chrome vanadium steel, specifically selected for its strength and durability characteristics. Each steel billet undergoes spectroscopic analysis to verify exact chemical composition. Carbon content must be between 0.38 to 0.43%, chromium between 0.80 to 1.10%, and vanadium between 0.15 to 0.25%. The hot forging process is mesmerizing to watch. Steel billets are heated to 2,100 degrees Fahrenheit in computer-controlled furnaces, then precisely formed using 500-ton hydraulic presses. The forging dies are CNC machined to tolerances of plus or minus 0.0002 inches, creating the basic wrench shape with perfect material flow. The controlled cooling process is critical. Wrenches are cooled in stages to achieve optimal grain structure. Too fast, and the steel becomes brittle. Too slow, and it loses strength. Temperature monitoring systems track cooling rates to ensure consistent metallurgical properties. The machining process showcases Taiwan's legendary precision manufacturing capabilities. CNC machining centers, equipped with ceramic cutting tools, machine the wrench openings to incredibly tight tolerances. We're talking plus or minus 0.0005 inches for a 15 millimeters wrench opening. The surface finishing process uses progressive grinding operations that achieve mirror-like finishes while maintaining precise dimensions. Each grinding wheel is diamond dressed to ensure consistent cutting action and surface quality. Heat treatment is where science meets art. Wrenches are heated to exactly 1,475 degrees Fahrenheit in protective atmosphere furnaces, then oil-quenched and tempered to achieve 44 to 48 HRC hardness. This specific hardness range provides the perfect balance of strength and toughness, hard enough to resist deformation, tough enough to avoid brittleness. Johnsway's quality control processes are legendary in the tool industry. Every wrench undergoes dimensional inspection using coordinate measuring machines accurate to plus or minus 0.000005 inches. Hardness testing verifies heat treatment effectiveness, while magnetic particle inspection detects any microscopic cracks. The torque testing process is particularly impressive. Automated testing systems apply loads up to 150% of rated capacity, while measuring deflection with laser interferometry. Wrenches must return to their original dimensions after load removal. Any permanent deformation results in rejection. Surface finish inspection uses profilometers to measure surface roughness, ensuring consistent appearance and corrosion resistance. The chrome plating process adds both beauty and protection, with thickness controlled to plus or minus 0.00005 inches. The final assembly process brings together precision manufacturing and human craftsmanship. Each wrench receives final inspection by trained quality technicians who verify every dimension, surface finish, and functional requirement. The laser engraving process adds size markings and the Johnsway logo with precision that will last the tool's lifetime. Each wrench is individually tested for proper fit on precision reference gauges before receiving final approval. What you're seeing is more than just tool manufacturing. It's a testament to Taiwanese precision manufacturing excellence. These wrenches will serve professional mechanics for decades, maintaining their accuracy and reliability through countless uses. In our next segment, we'll explore a completely different kind of precision manufacturing. Step into the world of Duke's cricket, where traditional English craftsmanship has been perfecting the art of cricket ball manufacturing for over 230 years. Located in Kent, England, This remarkable facility produces the iconic balls used in international test cricket, including the Ashes series. What makes Dukes special isn't just their history. It's their unwavering commitment to handcraft precision in an increasingly automated world. Each Dukes ball represents over 40 individual hand operations, performed by craftsmen whose skills have been passed down through generations. These aren't just sports equipment, they're precision instruments that can swing, seam, and bounce with characteristics that can change the outcome of international matches. The heart of every Dukes ball is its cork and rubber core, hand-wound with precisely 95 yards of wool yarn. The winding tension must be absolutely consistent. Too tight, and the ball becomes hard and lifeless. Too loose, and it lacks the responsiveness that makes cricket exciting. Master craftsmen can judge proper tension by feel alone, a skill that takes years to develop. The leather selection process is equally critical. Only the finest English hides are chosen, with leather thickness measured to ensure uniformity within plus or minus 0.5 millimeters. Each hide is hand-inspected for grain quality, strength, and flexibility. The cutting process uses traditional patterns that have remained unchanged for over a century. What's fascinating is watching the hand-stitching process. Each ball requires exactly 72 stitches using waxed linen thread. The stitching technique isn't just functional, it's an art form. The seam height must be precisely 1.5 millimeters, and the tension must be uniform to ensure proper aerodynamic properties. The shaping process combines traditional tools with modern precision. Hand-operated presses apply exactly 2.5 tons of pressure to achieve the perfect spherical shape. The pressing time and pressure must be precisely controlled. Master craftsmen use their experience to judge when the ball has achieved optimal density and shape. The lacquering process adds the distinctive Dukes shine while protecting the leather. Multiple coats of traditional lacquer are applied by hand, with careful attention to maintaining the natural leather texture that affects grip and swing characteristics. Each coat must dry completely before the next application. The stamp application is the final step. Each ball receives the iconic Dukes crown logo, applied with heated stamps that embed the mark permanently into the leather. Serial numbers track each ball's production date and craftsman, ensuring complete traceability.